everyone and welcome to our channel AKU Explanation. This is our part 6 of Matter in Our Surroundings, and I hope that you must have watched part 1 to part 5 before starting ahead with part 6. And as we have reached part 6, so I hope that you are liking my videos and I hope that you can see our efforts. So please like the video and write in comments if you want any extra thing in my videos. So in my last video I taught you about latent heat and sublimation and also effect of change of pressure. How you can check in our description box to get the videos of that part. In this video I'm going to start with evaporation. So evaporation is a word you must have heard from your very small childhood, that evaporation is the process of a liquid changing into vapor or gas even below its boiling point is called evaporation. Yes, this is the definition of evaporation. You should learn this because in exam these kinds of definitions are commonly asked questions. Okay, so now factors affecting evaporation. So before starting this part I want to I like to tell you that how actually evaporation is taking place, because definition and all and the what is evaporation you all know, but now since you are in class 9 you should also know that how evaporation is taking place. So that is also very important. Okay, so process of evaporation I will explain you with some small diagrams. So I hope you all understand, and if you understand please like the video and subscribe our channel. So we know that particles of matter are always moving and are never at rest. I told you this in my previous videos, that these are particles of matter and they are always moving and they are never at rest, moving in random direction. The Brownian movement which I told you, yes, Brownian movement, in which particles of matter are always in the zigzag motion. Yeah, yes students. So now just suppose that at a particular temperature, the temperature is fixed now. Okay, we are not taking any consideration of temperature. These are the particles of substance and the temperature is fixed. So at any given temperature in a gas, liquid or solid, there are particles with different amounts of kinetic energy. So these are the particles. Some particles will have high kinetic energy, some will have low kinetic energy, some will have in moderate, some will have a bit low than the higher one. So each and every particle is having different kinds of different amount of kinetic energy. In the cases of liquid, now we'll talk about liquid because we are talking about evaporation, and in evaporation what happens? Liquid gets converted to vapor. So in case of liquids, a small fraction of particles at the surface having higher kinetic energy. I told you that different particles have different kinetic energy. So in liquid also we have particles. So when they are at surface, some of the particles, just suppose that this particle and this particle is having high kinetic energy as compared to the other particles around it, is able to break away from the forces of attraction. These particles, they are able to break away the forces of attraction. This is also a very common thing that you all know, that particles, they always have some kind of attraction between them, and this because due to this attraction they are in the liquid form. When this attraction will be very high, then they will be in solid form. The attraction is very low, then they will be in gaseous form. So in liquid the attraction is somewhat in between to solids and gas, so they are having some attractions between each other. So since I told you that this particle, this particle and this particle is having high kinetic energy as compared to other, so these three particles, what we will do, they will move very randomly from one place to another. So they will have the potential to break these bonds between them and to come out of the liquid form. So these three particles, they will come out of the liquid form. As soon as they will come out of the liquid form, that means their attraction between the particles is getting low, is decreasing. Now, if after liquid, if attraction between the particles is getting low, that means they're converted to which state? They're converted into gaseous state or vapor state. I hope that you all are understanding all these things, because I'm giving all the examples through which you can understand easily. But still, if you have any doubt, any problem, just tell me in the comment box so that I could do the rectification. So they will be able to break away from the force of attraction of other particles and gets converted into vapor. This phenomenon of change of a liquid into vapors at any temperature below its boiling point is evaporation. Always remember that evaporation and boiling, they both are different things. Never get confused between these things. Why we say that evaporation and boiling are different things? Because boiling occurs at a specific temperature. For example, for water, what is the boiling temperature? This is 100 degrees Celsius. But evaporation can take place at any temperature, but not at the boiling temperature of any particular liquid. You take any particular liquid, just take, for example, water. Very simple example. Water's boiling point is how much? 100 degrees Celsius. But when we are observing the evaporation process in water, will not take the consideration of 100 degrees Celsius. Will always take consideration below temperature. You take 99, you take 87, you take 20, whatever temperature you take. At any temperature when evaporation is taking place, we take that in consideration, but not the boiling point. So now you understood what is the difference between evaporation and boiling. Still, if you have any problem, ask me in the comment box. So evaporation takes place at any different temperature than boiling point, not at the boiling point. So this was the process of evaporation, how evaporation takes place. Now beginning with factors affecting evaporation. This topic means what are the different factors through which increase or decrease the rate of evaporation. So our first point, our first way through which we can affect the rate of evaporation is an increase of surface area. Now understand how this happens. We know that evaporation is a surface phenomena. What does that mean? Evaporation is a surface phenomena. That means evaporation is directly affected due to surface. If surface is high, evaporation is also high. So that means we can say that surface directly proportional to evaporation. Let's take an example. You have a plate here, okay, and you have a glass here. You put some water here, and you put same amount of water, same quantity of water in the plate. Put these two containers below the sun for some hours. You will observe that the amount of water after few hours in this plate has become low as compared to the amount of water in this beaker. So amount of water in the beaker was higher than the amount of water in the beaker after some hours when you put these two containers below the sun. Why is this happening? Because the surface area, the amount of surface which water is getting in this plate is higher than the amount of surface it is getting in this glass. So if the surface area is increased, the rate of evaporation also increases. That is why whenever your mother spreads your clothes for drying in the sun, what she does, this is your wire, right? She never puts clothes like this, just put them, like throw them on the wire. Never. What she does, she spreads the clothes. Why? Because when we spread the clothes, the surface area gets increased. Yes, but when we just throw them or just put them on the wire, the surface area is less. You can understand this. Suppose this is a cloth. Okay, your mother has washed. My hands are clothes. Okay, when you put this clothes like this, when you put this clothes like this, what is the surface area here? So here the surface area is just this much. This is the surface area. But when you open this cloth like this, you open the cloth. Now what is the surface area? This part, whole part. This whole part is your surface area. So surface area is increased. So when surface area will be increased, evaporation will also be increased. So this is for our first part. Second part, an increase in temperature. When temperature is increased, evaporation also increases. This is a very basic and common sense thing, that evaporation, that means liquid to gas. When you apply heat to or temperature to a liquid, it gets converted to gas. Yes, so increase in temperature will increase the rate of evaporation. Why? Because when you increase the temperature, the kinetic energy of the particles which are present in the liquid, that also increases. Kinetic energy means what? Randomness. Yes, so when you increase the temperature, they will move more fastly, and if they will move more randomly, more Brownian movement, that means then the attraction between these particles can be broken easily, which I told you in the process how evaporation takes place, that when kinetic energy is high, then they are able to break the bonds between them easily. So if kinetic energy will increase with increase in temperature, kinetic energy is directly proportional to temperature, and temperature is directly proportional to evaporation. That means we can say that kinetic energy is directly proportional to evaporation. So if kinetic energy is high, evaporation will be high. Why? Because then particles will be able to break the bonds between them and get converted to gaseous form from the liquid, and this process is called evaporation. Third point, a decrease. Here remember, it is not increase, it is decrease in humidity. Humidity is the amount of water vapor present in the air. So when humidity is decreased, evaporation process, it happens fast. Fourth point, an increase in wind speed. It is a common observation that clothes dry faster when in a windy day. With increase in wind speed, the particles of water vapor move away with the wind. So these are the particles of water vapor, they move away with the wind. When wind blows, these particles will also move. So this will cause what? This will cause your change in the state of matter from liquid to gaseous state. So decreasing the amount of water vapor in the surrounding. So students, this was our end of this part, but still some more points are left in our matter in our surroundings. So I will complete that part in the next your next part, that is seventh part. So thank you so much for watching my videos, and please like our videos, subscribe and share them to a lot of students. Thank you so much.